to say on the recordings if people are having to watch these later or whatever. Okay, first of all, everybody on here should have received an invite for the next course in the series in Canvas. Okay, you should have all also been able to see my announcement that I posted last night, that I was basically updating you on what our scheduling is looking like and where we're going with this whole thing. I want to remind everybody that just because we're wrapping up one of our classroom courses, that does not mean your shop has been forgotten about. This is extremely important to say. Okay, just because we're doing a final exam tomorrow or Friday, okay, for the classroom portion of this course, it does not mean your shop has been forgotten about. And if you look in the announcements, there's a pretty decent write-up of what the plans are for the rest of the term and the best information that I can give you as of last night at 4 o'clock or whenever I wrote it. Because I've been in meetings all day on this usually after we have our classroom sessions. So having said that, there's two other things I want to bring up. First of all, for all of those of you who've been working hard on schematics, I want you to go back and take a look at the first couple schematics you turned in at the start of the course. If you have it on paper, take a look at them. Then take those schematics and compare them to the most recent schematics you turned in to me. For probably 80 to 85% of the people in this class, your schematics have become excellent. Okay, you guys have made a tremendous improvement in schematics, and I just want to acknowledge that to everybody. I know I'm relatively tough on schematics. I sort of insist on them being correct, but just about everybody here has made a tremendous progress on schematics. And keep that up because you're really doing good with them. So again, you've received an invite in Canvas to your next course. Please accept that invite so I know you have access. Okay, it's very important you accept that invite, go into the course. It shows up on the logs that you have access. Okay, I have to turn that report into your Campus Director of Operation, your CDOE, to make sure everyone knows they have access. Okay, if for some reason you have not received an invite, just send me an email or a message, private message in Canvas. I will resend the invite. I'll figure out what's going on. Okay, now, today, I need to finish up our oil pump or our fuel unit or oil pump or whatever you want to say conversation from yesterday. Okay, that's primarily where we're going to start today. We're going to talk a little bit about pump servicing. Going to talk more about those fuel units. I have a couple of the handouts that are on today's course page, okay, that are on the module for today. There's some additional handouts. I want to take a little bit of a look at these two here, the Suntech oil pump and the Webster service manual, because there's some stuff in there that's relatively important that I want to point out to you. The other thing we're going to talk about is we're going to talk about oil pumps, the oil solenoids. Okay, remember I've shown you some ignition transformers, some primary controls that have an oil solenoid that sits on the oil line and actually prevents the flow of low pressure oil to the nozzle. We're going to talk about that today as well. Okay, plans for the rest of the week. Tomorrow's going to be a really, really light lecture. We are basically I'm going to keep it short tomorrow. Friday, you have a final exam. We will not have an online session Friday because I want you to 100% concentrate on your final exam, and I want you to get it right. Remember, you'll have 2 attempts. Okay, first attempt, I want you to try to do it on your own. Second attempt, you can use available resources, and the system will automatically keep the higher of the 2 grades. Okay, take your time because there's plenty of time for it. I went over a little bit yesterday what's on about the number of questions and stuff like that. If you weren't on my call yesterday, go back and listen to the recording. So, any questions at this point?
No, sir.
Nope.
Sometimes I think there's only 2 people on my call. So, okay. Let's talk about pump service. Got to do something about these PowerPoints. Words bouncing around just drive me insane. Okay. When we're talking about 1 and 2 pipe systems, okay, our biggest issue, as I mentioned yesterday, is air. Okay, air in an oil line just doesn't work together, doesn't work well. Okay, air in any oil system is a bad thing. Now, when we're looking at an oil line that's running across a basement, okay, and let me just do one of my lousy drawings again. Okay, I have an oil tank sitting here. It might be one side of my basement. I have the oil line coming out of the tank, might be going around the walls. It's usually enclosed in plastic, and it comes to my burner that's mounted on my furnace. Connects to a valve here. There's a whole valve assembly and stuff like that there. This line that goes across the basement cannot have any compression fittings in it. Who can tell me what a compression fitting is? Does anybody know what a compression fitting is? Has anybody ever had to pipe a kitchen or a bathroom faucet or something, or maybe an ice machine on a fridge? Has anybody had to connect those?
Does it change the size of the pipe or the pressure?
Yeah, it actually, it has your pipe coming into it, and then it has a little loose sort of a metal band or a vinyl band that goes around the pipe, and then the nut goes over that, and it all screws together, and by the pressure on that fitting, it actually clamps the pipe in. Have you seen those before?
Yeah.
Okay, that's a compression fitting. You cannot use them on oil. They leak. Okay, so it is actually illegal to use those type of fittings on the oil. The only thing we're allowed to use on oil lines is flare fittings. Now, a flare fitting, you take the end of the pipe and you actually use a flaring tool, and you create a sort of a, this is supposed to be like a cup size thing, and the nut fits over this, and because this is actually part of the pipe and it clamps down to another fitting, a brass fitting, it makes a very solid seal. There's no way for it to leak unless you make a bad flare. Okay, so the only type of connections that you're allowed to use in an oil line is flare fittings. You may not use compression. Okay, has to be flare. Okay, because the compression fittings leak. Now, they may not always leak oil out because oil's pretty thick. Okay, oil has a little bit of a resistance to flow to it. It has viscosity. Okay, but when I start this oil pump, do I create a vacuum? When I start the oil pump, does it create a vacuum?
Yes.
Yeah, we talked about that yesterday. What is a single stage pump? How much vacuum can it pull?
10 inches.
Yeah, 10 inches. What about a double stage pump, dual stage?
Is it 20?
15. Close. Okay, so we go from 10 to 15. Okay, can it handle up to 20? Yeah. But what's our rating is what I'm looking at. Okay, 20 was a number that was tossed out there yesterday as it can handle that vacuum equivalent in a line. If we use two pipes. Okay, so but air in a line will get in here based on that vacuum. If that pump is having to pull, okay, because we don't have a perfect gravity flow system, air will actually get pulled into these oil lines pretty easily. Air can cause a pulsation in the fuel flow as air bubbles go to the nozzle. It can cause change in flame. Okay, and the more important thing is that when the burner shuts off, an air bubble that's in the nozzle side that might be caught in the nozzle filter or something can actually break the vacuum that's created and allow the nozzle to drip unburned fuel into a hot combustion chamber. Okay, now to give an idea of what this is you all know that if you have a straw in a glass of water, okay, and you put your finger over the straw and lift the straw out of the water, you're going to hold water in that straw. You move your finger, you break the vacuum that's holding the water in that straw, that water's going to fall out of the straw. The same thing happens with a nozzle. When this fuel pump shuts off, I now have a vacuum. Okay, I have oil all the way through that nozzle. The oil hasn't come out of that nozzle, but I have a perfect vacuum where we're now holding the siphon that's in that nozzle. If there's air in the nozzle, it's going to allow that unburned oil to slowly drip out of that nozzle. When that oil drips out of the front of that nozzle, okay, you have your nozzle front that's in your hot combustion chamber. This nozzle out here is still hot. Okay, it's metal. It's been against a flame. That nozzle is hot. Okay, that unburned oil will evaporate. The water will evaporate out of that nozzle. Okay, and it will actually create sort of a carbon, or we call it a coke buildup on the end of that nozzle and on the end of the nozzle assembly. It will really hurt the burner and the flame as time goes on. Okay, if you ever show up to a oil system and there's a whole shield of, it almost looks like a carbon soot, a hard soot buildup on the end of a nozzle assembly. It's because there's air in that oil line. Someplace in that oil line there is a leak. Okay? So basically, we always have to make sure that there's no air in a system. Anytime you service an oil system where you've opened the oil line, this includes changing a filter, replacing a valve, replacing a nozzle, you absolutely must bleed the oil system to remove all air. Okay, on every oil pump, and I'll show you a picture here eventually, okay, there's a little bleed valve, okay? You start the unit, you open the bleed valve, okay, and you feed it by gravity. Now, the bleed valve shoots oil out of it, so perhaps you want to put something under it to capture that oil because the homeowners hate oil on their floors, okay? Two-pipe systems, okay, are self-priming. So if you have a two-pipe system, we talked about this a little bit with dual-stage pumps, but if you have a two-pipe system, they're self-priming. Okay, you still have to be there while they prime because A, you have to make sure it works properly, and B, what's going to happen about 45 seconds after you start that oil pump if there's no oil flow? What's going to happen 45? Yeah, what's going to shut it off? The primary control, right? It's going to trip on a primary control. There's no flame. I have no oil. There's no flame. So while we're bleeding the oil, while we're bleeding the air out of the system, we have to bypass the safety, basically. We have to pretend there's flame and there's no flame there. So how am I going to do that? What do I have to do to pretend there's flame and there's no flame? Here's my primary control. I have a bunch of terminals on the side. I have a TT. Okay, I have an FF. What do I have to do to make the burner feel that there's flame there so that it keeps running to prime the pump? Anybody?
Add light.
Well, now add light is sort of a correct answer, but when my CAD cell sees light, does it have a low resistance or a high resistance?
Low.
Okay, so if I start my oil burner, okay, because it won't start if the CAD cell's seeing light, right? That was part of what we talked about primary controls. They won't start if the CAD cell's seeing light. But once my oil burner is started, what can I do to this primary control to make it think it's seeing light?
Do you jump F and F?
Exactly. Okay, now, this is one of these things where oil technicians wish they had 3 hands. Because you're holding a bucket down here to capture the flow of oil, to capture the oil. Okay, on the little oil bleed valve, okay, it's just a little 3/8 inch nut. Okay, what it is. It's a 3/8 inch nut. You have a little plastic tube on there that you're trying to keep in this bucket. You're using your open-ended wrench to open that 3/8 inch nut. Okay, so that you can let the oil bleed. Well, remember the other day, you might have missed it, but I said this FF terminal is the exact distance apart where you can take that 3/8 inch open-ended wrench that you're holding, that you've opened that oil bleed valve, and you can put it across those 2 terminals. And it will actually keep the burner running while this valve is open. Okay? Basically what you do is you start the burner, let it start, okay? Immediately open the 3/8 inch wrench, the valve, the bleed valve, and then immediately put your box end, the open end wrench, across the FF terminal. That will keep the burner running until all the oil bleeds, until all the air bleeds out of this into the bucket you're trying to balance under there. When you have a clear flow of oil, you can remove this wrench and very quickly close the bleed valve. You have 45 seconds from the point you remove the wrench to closing the bleed valve. Okay? Got to do it fast, and you got to not spill any oil anyplace. Once you close this bleed valve, the flame will start. Okay, the bleed valve prevents oil from going to the nozzle. Once you close the bleed valve fast, this flame will start. Okay? And because you've used the same wrench to close this bleed valve, okay, guess what? You never have to worry about forgetting to take off this jumper. Okay? You have the jumper in your hand. Questions on that?
Nope.
Okay, it's pretty straightforward, but this is a place where oil burner technicians, especially ones new to the field, have a lot of issues with this. Okay? How do I tell if there's no more air in the system? How can I tell when I'm looking at the oil? How can I tell if it's air-free?
There's no bubbles?
Well, yeah, it is actually a weird type of bubbles. Air coming through the oil burner will turn that oil into sort of a milky. It's a very small, foamy type of bubble. Okay? Once there's no more air in it, I have a red stream, okay, of steady, clear, reddish oil, okay? There's a big difference in the air in the oil and no air in the oil. If you have any type of foam coming out of here, foamy bubbles, you still have air in that oil line. And if you bled a gallon of oil out of this thing and still have air in the oil line, you need to go find your leak, okay? Because there's a problem someplace. There's been 2 very important pressure tests, okay, that we do want people to realize. And you're going to practice this stuff in the lab, but the stuff I wanted a little bit go over just to make sure we've gone over it. Okay, there's 2 important pressure tests. We have a field pressure and a cutoff check. Oil burner technicians carry, and most often your company will supply this to you, they carry 2 pressure gauges. Well, one's a pressure gauge and one's a vacuum gauge, specifically designed for oil. Okay, we disconnect the fuel line from the nozzle port, and we put a pressure gauge into the system. We basically attach a pressure gauge, and we operate the burner. We, in other words, turn it on, jump out the CAD cell, and we adjust the burner or the pump to the proper pressure. Okay? We shut it down and we watch the gauge. It should drop a little bit and stop. It's not going to go down to 0. Drop means it might go from 100 psi to 70 psi. It will never go down to 0. If it continues to drop again and goes down to 0, the pump is bad. Okay, so again, pressure test. Okay, we've put a pressure gauge into the fuel line that normally goes to nozzle. Okay, we operate the burner, we make sure the pressure is adjusted properly to either the 100 psi or the 140, and then we shut the burner off and we watch the gauge. It should drop and stop. Okay, not at 0. If it drops again or slowly creeps down to 0, the pump's bad. Okay, replace the pump. We can also do the same thing while it's running. Okay, we can insert a pressure gauge into a gauge port or a bleed port. If you watch the pressure gauge while it's running and while it's providing fuel to the nozzle, if the reading on the pressure gauge is pulsating, it means the pump strainer is clogged. And we'll talk more about that when we talk about taking apart the pumps. Okay, it means that there's a pump strainer that's clogged, or the oil filter on the tank is clogged, or there's air in the pump. Bleed it out. Okay, so pulsating readings on a pressure gauge while the system is running is one of these 3 items. It's actually pretty easy to troubleshoot an oil burner. 9 out of 10 times problems with oil equipment on the mechanical side is air. There's air in the system someplace. Okay? Fittings wear out over time. Gaskets wear out over time. Something is letting air into a system. And just because there's oil in a line, the oil may not be leaking out. It might just be allowing air in. Okay? There's one final check that we do on fuel pumps. Okay, we do a vacuum check. Now, this uses the second gauge. It doesn't use your pressure gauge. It uses a vacuum gauge. Okay, we use it whenever there's a problem with a fuel pump. In other words, whenever I'm not getting enough oil, whenever I have a feeling that I just might not be pulling enough oil, we install a vacuum gauge into the pump's inlet port. That's where we normally pull the oil in. We turn the pump on. Okay, again, bypass the CAD cell. Turn the motor on and let it run because we're not pulling any oil. We're putting vacuum on the pump. I'm fine with it running. Okay, the reading should be within the pump's requirements. 10 inches of vacuum on a single stage pump, 15 inches on a dual stage pump, and if I really want a dual stage pump, okay, I might go for 20 if I have a return line. Okay, but there's several rules of thumb with it. Okay, again, those are just what I gave you. You have your 10-inch and your 15-inch. The majority of pumps you deal with are going to want to pull a 10-inch vacuum. If I'm only pulling a 5-inch vacuum, what am I going to do? If you put a vacuum gauge on and you only pull a 5-inch vacuum, what are you going to do?
Check for a leak.
Well, I would have found the leak on the air side, right? On the pressure side, right? This is just on the pump, okay? The vacuum gauge is just on the pump. It's not pulling the whole oil line. So if I'm not pulling a 10-inch vacuum on a single-stage pump when I'm just testing the pump, what am I going to do?
Do you replace the pump?
Yeah, just replace the pump. Okay? Now, if my pump tests out okay, so let's say I get my 10 inches of vacuum with just checking the pump. What's going to be my next step? And this is okay to guess. It's okay to be wrong. Okay? What is my next step with my vacuum installed on my vacuum gauge installed on the pump. What am I going to check next?
Check the outlet.
Well, what if I then check the vacuum all the way back to the tank? Okay, so my burner's over here. I have a whole bunch of fittings. I might have a valve right there. I might have a connection right there. I have an oil filter over there. I have another valve right here. Okay, could I close this valve and then check the vacuum all the way back to there? Is that a worthwhile check to make?
Yes.
What am I going to find? Well, okay, what should I find? Should it hold a vacuum?
Yeah.
Yeah. So if I install a vacuum gauge, if I have this vacuum gauge on this inlet port, by the way, there's 2 inlet ports on your oil pumps. If I run this vacuum, eventually it should have the same vacuum or close to it that just was on the pump, because I'm pulling on this. I have a valve closed right here. When I shut my pump down, it should hold that vacuum. If this vacuum releases on this line, okay, I have a leak someplace. Who here has an older house where you might still have an oil line under your basement floor?
Yeah, I do.
Okay. Can you see that oil line?
No.
How do you know if it has a leak?
Yes, you don't.
That's the problem. That's why all new construction oil lines can no longer be buried under concrete floor. What happens when concrete and copper come in contact with each other? There's an electrical reaction that happens. It actually corrodes the copper away. So oil lines that have been buried under concrete floors have a tendency to spring leaks. Okay, I want to say about 12 years ago, I was actually an expert witness in a case that was in Hartford, the Hartford court systems, where an oil company came out and did a service call. And the reason the homeowner called the oil company is she felt her oil usage was higher. She was an elderly lady, and she felt her oil usage was higher than it was supposed to be. She was on an automatic fill with the oil company. She had gone from using probably 100 gallons of oil a month, which again, she was really energy conscious. She never turned her thermostats up. She used very little hot water. She had, over the course of a 6-month period, gone from using 100 gallons of oil a month to using over 200 gallons of oil a month. Okay, and the oil company came out, the service company came out, serviced the burner, couldn't find any reasons, and basically wrote it up on the service ticket where she was, where they felt she was increasing the heat in her house, where she wasn't keeping the thermostat as low as it was. They came up for every reason in the book why the oil was being used more, including a service technician actually wrote on a service slip that she's elderly and because of mental state, she doesn't remember what she was turning her thermostat to. Okay, now that, number one, is a big problem. Just there, right there. I would have fired the service technician on the spot. But that was written on a service ticket. The reality was, is that the oil line had a compression fitting in the center of the oil line as it ran under the basement floor. When I first saw the house, okay, the basement, the basement floor was completely jackhammered out. The boiler and the oil tank was sitting on 6-foot-tall supports. They had to take the basement floor out and take the dirt out 6 feet under the floor level to do an environmental cleanup of the oil spill. Around the outside of the house, from the foundation to the downhill side of the house, was about 400 feet of trenching that was done to remove the contaminated dirt. The oil company was refusing to pay for the environmental cleanup. Now, why should they have paid for the environmental cleanup? Why were they liable? Why was the technician liable?
Because it wasn't up to code.
Well, 50 years ago when the system was installed, the code was different. Okay, older house under the basement floor. But why was the technician personally and the oil company liable?
Because of the service ticket they wrote?
Well, it actually was a two-pronged situation. That was part of it. If an oil company has you on autofill, what is one of the things they're supposed to be watching for? Increased oil usage. Her oil usage doubled per month, and nothing changed in the house. Okay? They're supposed to be flagging that. Okay, they're supposed to be, okay, either the burner's not running right or there's a leak. Okay, if oil usage doubles, the oil companies are supposed to be flagging that. Okay, any increase of usage that's not temperature related, outdoor temperature, the oil companies on the autofill need to be flagging. They were happy. She was using more oil. They were making more money. But the reality is that should have been flagged. Now, why was the service technician liable? Even forget about the point he wrote on the ticket. Okay, he'd been out there 6 times. Why was he liable?
He could have replaced the compressor fitting.
Well, he couldn't see it, but what could he have done that we teach that at any school, even the apprenticeship system teaches every single student that goes through the school? What did we just talk about? Guys, the vacuum checks. Had he run a vacuum check and documented it on the service ticket that it didn't hold a vacuum and it didn't pass a vacuum test, and therefore there's a leak between point A and point B, and we cannot check what's under the floor, so we have to run a new oil line above the floor over to the burner, that technician and that company would not have been liable. What does a license basically say to anybody out there? What does a license mean?
That you can do your job
Why do we have to
correctly?
be licensed? Go ahead, say that again.
So you can do your job correctly?
It basically means you have been trained, you have had an apprenticeship, you have passed a course, and you have taken an exam that shows you know what you're doing. So after you're licensed, if you skip a basic check and cause damage, any court in the country is going to hold you liable. This is pretty serious, okay? This was a $5 million lawsuit. Homeowner won. Okay, put a company out of business. Okay, this is a pretty serious situation. Once you are licensed, once you have the course knowledge, you guys gotta do the job, okay? It takes time to do a vacuum check, and if your dispatcher's breathing down your neck, you have to say, listen, I have to do this vacuum check before I can leave. Yeah, but you have 20 other calls to get to. Sorry, I gotta do this vacuum check. I cannot leave without doing it. Okay? And I know there's someone in this course that actually has, that actually works in the field already, and they could probably they could probably agree with me on dispatchers breathing down people's necks. But you have to do the vacuum checks, okay? It is irresponsible not to do it. Okay, it's part of a yearly preventative maintenance. Anytime there's air, anytime there's flame problems, you've got to do the vacuum checks. Okay? One pipe system. Okay, I have to be able to maintain a 6-inch vacuum. 10-inch on a 2-stage system. That's my full vacuum check. 15-inch on a 2-stage 2-pipe system. Okay, rules of thumb. Have to be able to maintain these vacuums. If I don't have a vacuum, I have an air leak in a suction liner fitting, I have a leak at a pump gasket, it's still a leak. Or I have worn gears on a pump. All of these things have to do with poor vacuum. Okay? There's a strainer in the pump. That's the only thing you can service inside an oil pump. It's the only thing that you can change out. You're not going to rebuild a pump. You're not going to change the gears out. You're not going to change the parts out. The strainer is the only thing you can change out. Other than that, you're going to replace the pump. Okay? Always follow manufacturer's recommendations. Anybody know why I say that? Always follow manufacturer's recommendations. Anyone want to guess why I tell everybody that?
It might be slightly different.
Saves you from liability.
That, quite honestly, both are very good answers. Okay? Yeah, every manufacturer might have a slightly different pump. As a matter of fact, I think they do this on purpose. But the other thing is, saves you on liability. Saves your employer on liability. Don't be a mechanical engineer. Because Joe Attorney, when he has you in court sitting on the witness stand after you have blown up somebody's house or caused an environmental catastrophe, okay, the first question he's going to ask you is, hey you, where did you get your mechanical engineering degree? You can't answer that one because you don't have a mechanical engineering degree. Okay, right there you're liable. Case closed. Always follow manufacturer's suggestions and recommendations. Don't do anything that the manufacturer doesn't tell you to do. Pumps have different rotation. Could be clockwise, counterclockwise. Pumps have different RPMs. And pumps have different types of mounting, how they mount onto the burner. Rotation is always looking at the pump from the shaft end. In other words, you are holding it in your hand and you're looking at it at the shaft. It's either clockwise or counterclockwise from the shaft end. That's the rotation of the pump. RPM, 3450, 1700, whatever. Different RPMs are out there. Types of mounting is, where is the mounting bracket? Are they on the 3 portions? Okay. Sorry about the things that look like ears. They're not meant to look like ears. Okay, are there 3 mounting brackets? Are there 2 or are there 4? Types of mounting makes a big difference. Okay? They're not interchangeable if those things are different. Where's the discharge port? Is it on the right or left? Again, you're going to read all pump information from the shaft side. Holding in your hand, looking at the shaft, where are the different components? Shaft sizes are different. Now, with shaft sizes, a lot of times in the box with the pump, there will be little shims that you can put on the shaft to make them larger. So the pump may be shipped with a 5/16 inch shaft, but there's going to be a shim on it that pulls it up to 7/16. Okay, those are the two basic shaft sizes. Okay, noise in pumps. If the oil pump is noisy, like whining or a little bit of a rattle, it's going to be worn pump, worn parts. Could be a misalignment of the pump to the coupling. Okay, could be a missing anti-hum device. Believe it or not, they have an anti-hum device on some of the pumps. But my biggest problem with noise in a pump, air. Okay, bleed the pump before you do anything else. Okay, because air. If you have air in the pump and there recently hasn't been service, what do you need to do? If you find air in the pump and there hasn't been recent service, what do you need to do? Anybody?
You asked if there's air in the pump?
If there's air in the pump and there hasn't been a recent service call, they haven't run out of oil, no one's been there recently, and you find air in a pump, what do you need to do?
Do you bleed it?
What am I going to do before I bleed it?
That I don't know.
What about the vacuum test? That air came from someplace. Okay? Again, air in a pump. The air came from someplace. Okay? Oil line noise. This one is actually pretty frequent, believe it or not. Oil pump, oil line noise. Okay? We could have improperly fastened oil lines. There's vibration on these pumps. Vibration will run down a copper oil line very fast. Okay? Sometimes this is as simple as making sure there's a loop of oil line someplace, sort of like just a coil, a single 360-degree loop. That's not, you don't bend it, but you just loop it like it would have come out of the box. That will take care of that problem quite a lot. Fastening the oil lines down so they don't bounce around. Okay, making sure they're properly in the jacket that's required for new oil lines, either the plastic or the rubber jacket. Okay, again, there's an anti-hum device in some of the pumps. Most of them it's built in these days. Don't have to add it. But oil line noise is a real thing, especially when the pump shuts off. The oil line, when the pump shuts off, will jump around a little bit if it's not fastened. In the middle of the night, to some homeowners, that sounds like someone's in their basement. Okay, there's a noise that they can't identify. It wakes them up. And by the time they wake up fully, there's no way to hear that noise again. Okay, so it can actually drive people nuts. But again, careful about air. Okay, every single time I've seen a service technician ignore air, there's usually a big oil spill that has to be cleaned up. Okay, because where there's air, there's a leak. Unless, of course, the person runs out of oil. Any questions over what we just went over so far?
No, sir.
A lot of things covered in this, and again, once you are a licensed service technician, you do have some liability. Okay? Who's liable for your actions when you're in your apprenticeship?
The one you're working on.
Whoever the licensed technician is that you're working under. That's why apprenticeships are so important. Okay? You're learning still in your apprenticeship. Okay, oil line solenoid valves. Okay, we've already talked a little bit about the solenoid valve as an electronic valve. When you see it on a schematic, it has a very special symbol for the electrical portion of the solenoid valve. Okay, it's a coil with an arrow through it. Okay, that's a solenoid. and it's an electronically operated valve. The coil of wire is energized and creates magnetism. The magnetism either opens or closes a valve. A valve that's open when it's not powered is a normally open valve. A valve that is closed when it's not powered is a normally closed valve. So again, just like with contacts, I have normally open and I have normally closed valves. Okay, normally open valves, if I want to close them, I have to power the coil. Normally closed valves, if I want to open it, I have to power the coil. Okay, the solenoid valves are used in both older and newer burners. Older burners, this is something we add afterwards. It's a field installation. Newer burners, this valve is included with the burner itself. It's right on it's part of the burner. It's either on the oil line or it's part of the pump. The valve has two purposes. It delays the flow of oil to the burner at startup, and it provides a clean shutoff to the flow of oil at shutdown. So the first part of this, the primary control starts the burner motor, which is connected to the pump, okay, and we build up our oil pressure, and then we start the ignition sequence. So in other words, before the oil even gets to the nozzle, I know I have 100 psi or 140 psi of oil going to that nozzle. On shutdown, I don't have to worry about oil seeping by the pump. Okay, I have a solenoid valve there that's going to shut the oil off going to the nozzle. Okay, so the valve has two purposes: delay at startup, provide clean shutoff at shutdown. Okay, this is an oil pump, and this is what I wanted to show you when we were talking earlier as well. This is your solenoid valve. Okay, it plugs into an electrical connection right there. Okay, all of these nuts that are around here, okay, this is my outlet going to the nozzle, okay, but I have a couple places where I have inlets. Okay, I have an inlet right there, okay, where I could have in. I could have an outlet here going back to the tank if I wanted to make this into a two-pipe system. And right here is my pressure adjustment screw. It's a flat-headed screwdriver that fits in there, and I can adjust the pressures based on that. Okay, this is where I put in my vacuum gauge, and if I used a pressure gauge, I would put it on the outlet side. Okay, so you have an extra port there for a vacuum gauge. What's this right here that I just circled? What's this right there, if you had to guess?
Relief valve?
That's my bleed valve. This little nut, this is a flat-sided 3/8 inch nut that actually has a fitting on it that I could put a small hose on it. You know those clear little small hoses. I could slip that on the end of it, and I can open that up, okay, and it will bleed the oil out of the pump. The minute I open this, I have no more oil coming to the nozzle. Okay, so this is where I have to jump out the primary control while the pump is running with my 3/8 inch open-ended wrench that I've used to open this. Once I get a clear flow of oil, I can close this, okay, with that same 3/8 inch wrench that I just had in my hand already. Okay, I could do my pressure adjustments, I could check my vacuum. This is all here on the oil unit, on the fuel unit. Okay, this is my solenoid that's built in to the oil pumps, the newer pumps. Okay, that's the whole setup of an oil pump. Okay, by the way, if I pull out these screws, okay, on most pumps, there's a strainer under here that needs to be changed out. If the screws are impossible to pull out, don't attempt to force it because it means there's no strainer in it, okay, and it means you'll have a handful of gears if you open these up. So again, just make sure it's a pump that has a strainer in it. If you can't get the screws open, you'd have to use a pair of pliers or something to get them out and force them out, don't open the pump. There's no strainer in it. Okay, that's the solenoid valve. I can also just add a solenoid valve into the nozzle line. You put one there, that goes the outlet of the pump, and the oil comes through here. Okay, now, one thing you have to be very cautious about on solenoids when you install them, there's a little arrow stamped into the side of the solenoid valve body itself that tells you the direction of flow. Don't put them in backwards. Okay? Again, there's an arrow stamped on the direction of flow. Don't put these things in backwards. They don't work well. Okay? To delay at start, the oil pump is set for at either 100 psi or 140 psi. The pressure is based upon the burner motor operating the pump at full RPMs. There's a brief period at the start of the burner cycle that the motor, pump, and air fan are not moving at full speed. Oil delivered to the combustion chamber is not going to enter at the highest pressure. So what we do, the oil valve solenoid remains closed until the burner motor, the fan, and the pump all reach correct operating speeds. The solenoid then opens and allows the correct pressure and air mixtures to occur in the combustion chamber. Okay, we can also use this as a pre-purge in high-efficiency boilers. Okay, if used as a pre-purge, the primary control has to be set up for this. There's an extra wire specifically on the primary control for the solenoid. Okay, there's an extra wire. So a lot of times it's purple. Okay, there's an extra wire. If you're at a customer's oil furnace and are not able to solve a rough ignition problem through setting the pressures, cleaning, air adjustments, making sure there's no leaks, install an oil solenoid valve and the problem goes away. A lot of the older equipment should have had this installed and the manufacturers didn't realize they should have been installed. Or someone has changed a pump out along the last 50 years that had one of these installed and it was removed. So anytime you have like a rough ignition, and you can hear it once you get used to it, and you've cleaned and adjusted everything, throw in an oil solenoid valve and the problem goes away. Clean shutoff. I talked about this a little bit ago. When the call for heat is complete, the burner shuts down. There's a brief period of time where the pump is not delivering the correct oil pressure to the knowledge. That oil is going to drip out of the end of the nozzle and cause a buildup of carbon. It's what I talked about earlier with the air in the system as well. Same thing happens. Okay, but as that oil pressure drops from the 100 psi to the 70 psi where it should hold, there's going to be a brief period in there. And I mean, it's a brief period where the oil is not going to spray properly into the combustion chamber. Adding an oil solenoid valve solves this problem. It causes a clean shutoff. The valve closes at the end of the heat, call for heat, and before the pump and the burner lose pressure. Okay, I no longer have that brief period of time where I don't have enough pressure coming out of that pump. Oil solenoid valve is placed in what we call the jet line. Okay, and that's a new terminology for you. The jet line is the small copper tube that's between the pump outlet and the nozzle assembly. It's called a jet line. Don't ask me why. It's a 1/4-inch line, and it is easily damaged. Okay, it's a small 1/4-inch line. It's copper, easily damaged. But in order to install this solenoid valve, you need a second 3/4-inch line. For clean shutoff purposes, the oil solenoid valve is wired to the burner motor line at the primary control. Don't wire to the ignition transformer line if there's a separate ignition transformer line, because the ignition transformer might shut off as soon as ignition is proven. Okay, newer primary controls like the type I've shown you pictures of. Okay, the newer primary controls will have a line voltage coming in. It will have a neutral. And then it will have 3 wires coming out of it. Okay, it has an orange wire The orange wire always goes to the burner. It might have a blue wire and a purple wire. Okay, purple wire, you have to look at the diagrams on the box, but this could go to the solenoid. Okay, the blue wire would go to the ignition. Sometimes they're exchanged. Always look at the labeling. Okay. As long as you have all of these wires, you know exactly where things go. But if you only have one for the ignition and one for the burner, and you're attempting to add the oil line solenoid, always put it with the burner motor. Okay, because the burner motor runs through the entire cycle. The ignition transformer might not. Okay, this is a typical wiring diagram. This is an older primary control. You have a black wire that's going to your limit, that's your hot. You have a white wire, that's your neutral. And then you have an orange wire. On that orange wire, I'm going to have my ignition transformer, I'm going to have my oil valve, and I'm going to have the burner motor. They all come on and stop together. Newer controls may split these things off onto their own wire because the control cycles them. Sequence of operation matters. For delayed ignition or pre-purge, you either have to have a primary control that has a separate line from the solenoid or a solenoid that has an internal delay timer. I don't see these anymore. Okay, these are starting to go away. They've always been an issue. Most often we're seeing the separate line for the solenoid valve. Make sure you test any installation before leaving the job. Guys, I have to say this again. Make sure you test any installation prior to leaving the job. Run it through several cycles to be sure the delay will not trip the CAD cell safety. Okay? Anytime you modify something by adding an approved aftermarket part, a solenoid valve is an approved aftermarket part. You've been need to be sure that it's not going to trip the CAD cell, because I can guarantee it's going to happen on a Thanksgiving evening when you're the only one on call. Okay, this primary control, my CAD cell connections are right there, and if you look closely, I have a blue wire. Okay, what's labeled under that is ignition. Okay, over here it's labeled oil valve on the purple. Okay, I have a burner motor, that's my orange. My L1 is black, and my neutral is L2. I have some additional optional connections that I could go to an aquastat or outdoor reset. Okay, and this limit, you'll notice there's no pin for the limit. Okay, so there's nothing there. They use a standard body with a pre-printed thing. Okay, now, again, under here, okay, there's a label that tells the technician how to reset this control if it's totally locked out. Okay, this is normally on a wiring box. Line voltage connections are all made in enclosed areas. Any questions on solenoid valves or why we use them?
No, sir.
Okay. Okay, well, we have covered what actually, there's one thing I want to pull open, this Suntech pump handout real quick. If I don't cover that, I'm going to forget. So let me just open that real fast. Okay, Suntech is one of the primary companies that puts out oil pumps, okay? They've been around forever. This handout that is in your course under the oil pump module, okay, has the pump identification. If all you have is a model number on a pump and you really don't know what it is, okay, you can look at this diagram and it will actually tell you how to decipher the model numbers on the pumps. Okay, and it's sort of important. So again, grab this diagram. It comes with most pumps, but a lot of times, okay, it does not. A lot of times people just toss it out. The other really neat thing on this pump is it actually shows you the suction, the return, and all the different parts of the internal workings of the pump. Okay, it's sort of a cross-section plug. It's a cross-section of the oil pumps. Now, on this return port, okay, there's one very important thing, which is why I really wanted to pull this diagram out. Okay, on this return port, that would be the line back to the pump on a two-pipe system. There's a bypass plug. It comes in a little plastic bag with the oil pump. Okay, if the plug is put in, okay, it is going to be a one pipe. If the plug is out, it's a one pipe system. Okay, in other words, what that does, it allows the return inside the pump to actually recirculate the oil inside the pump. Okay, so if the unit is supplied for one pipe installation, the bypass plug is not installed. For a two pipe installation, okay, you have to pull the cover off of this return port. You install that bypass plug that is shipped with the pump, and then this return port has to be connected back to the tank. Okay, so the pumps are shipped for single pipe installation without the bypass plug installed. It comes in a little plastic bag. Don't toss the bag out. Hang on to that. You're going to need it someplace along the way. Okay, but this is a really neat diagram.
Can you purchase the plug if you do?
If you accidentally lose it, yeah, you could purchase the plug. A matter of fact, you just have to call your go into your supply house, walk up to the counter, say, need a bypass plug for a Suntech pump. The counter guy is going to laugh at you, sort of chuckle, you tossed it out, right? Yeah, I lost it. They'll give you one.
Okay, fair enough.
Be prepared for a little bit of ribbing from the counter guy.
So I'm expecting a whole lot.
Okay, so these again, this is just one of those handouts I would probably keep and save. Okay, there's a similar one there for the Webster pump. Okay, there's something very important about a Webster pump. Okay, you cannot open them up. They do not have a strainer in the majority of the Webster pumps, okay? Webster pumps are a little bit different. They actually grind up any materials that come into the pump. Okay, so the Webster pumps don't have that strainer that you can change out. So the Webster pump manual is, again, it's a neat manual. Sometimes you can't find them. Okay, but a lot of times they don't have that strainer. Okay, and this is a relatively long manual, so I'm not going to go through it. But again, this is one of these that again shows you how to do different things with burners, shows you what can be done with pumps. Okay, in other words, this shows you how to tee it off, shows you all the different configurations that you might run into. Personally, I think this manual is extremely important because people do not pipe things properly.
So it doesn't matter what kind of pump you have. This is sort of versatile to all. Yeah, because the pump is just sucking and supplying fuel. So if you have a water heater sitting next to a furnace, and if you go out onto a call that they're having problems with that water heater, that it keeps tripping on primary control, take a look at the wiring. Take a look at it. Take a look at the piping, I meant. Take a look at everything that goes along with it, because there's different things. Here, the oil pump is in the ground. You still see oil pumps in the ground. They're not new anymore, but they're still there. Okay? And there's different ways to deal with these. Tells you how to use your gauges. Tells you how to use your vacuum gauges, how to install your pressured vacuum gauges.
Even actually, this one actually the model code as well.
Yeah, so this honestly, especially if you're going to do a lot of oil, this is a really, really good one. And again, vacuum and vertical lift. How far can I lift oil with different vacuums?
Oh.
Okay, so there's a lot of good information in this manual. Okay, guys, honestly, that's all that I have for today. Tomorrow, we're going to have a brief lesson where there's just a few things I need to talk about. I'm going to keep it short. Friday, we have an exam. We're not going to have an online session on Friday because you have one focus on Friday, and that's to do well on your final. Okay, I don't think there's anybody in here that's in danger of failing their final exams as long as you've kept up with everything. The final has it will have 2 chances to do well on the final. You'll have 2 attempts, okay? And just follow the directions. But the first attempt, I really would like you to try on your own. Second attempt, available resources, I don't care, okay? So just it will keep the higher grade, but there's a little bit of trying to do something on your own the first time that will make a difference in your own confidence as well. Okay, any questions before I wrap this up?
Nope.
No, sir.
It's negatory.
Okay, you guys all have a great day. Thank you very much, and I'll talk to you tomorrow.
Leave it out.
Thank you, sir.